So in this video we're going to talk about symmetry, and some goals we're going to set is, first of all, we want to define what types of symmetry there are. And there's x-axis, y-axis, and origin. So there's three types of symmetry. What we also want to do is, given an equation, we want to be able to identify which symmetry to use. For example, let's look at some equations. So the first equation would be y equals x squared. And to graph that, of course, it would be a parabola, since it's squared. And what y-axis of symmetry, this would be a y-axis of symmetry because the y-axis is right here going up and down. And remember, this is the x-axis going left to right, and going up and down is the y. So imagine this visually. If you folded this in half, I know this isn't perfectly straight, but let's imagine it was. So you'd fold it in half, and this line over here, if you folded it, would overlap this line. And that's pretty much what y-axis of symmetry means. So another way to look at it is, if you had a negative term, pick a point. Let's say our point was right there, and its counterpart was right there. Its counterpart would be x, comma, y. And you see the y's are symmetric. So that's y-axis of symmetry. Now moving on to x-axis of symmetry. Whoops. Drop my eraser. X-axis of symmetry would look something like this. So y equals, say, negative squared. Remember, what this is just y equals negative x times negative x. And of course, that'll just give you that. So off the bat, you know it's x-axis of symmetry because this equation equals this. And to find that, you have a number line like this, and let's say we have something like that. Another parabola, and let's say it's 2 points right there, one right here and one right there. So we already know that this point is an x and a y, and then this point, again, use the visual example, visualize this in your head. What you do is you want to fold this so the lines overlap, and if the lines overlap completely, then it has x-axis of symmetry. So, and this one would be positive, and then we're down here, so we're dealing with negative y. And there again you see the similarities and the consistency on that. So that was x-axis of symmetry. And finally, the last maybe not the most common, but definitely out there, is called origin of symmetry. And for origin, the equation is y equals 1 over x. So if we were to draw this out, it would look something like this. Remember your lead term, like that. Two lines going like that, right? and imagine it visually. Origin just means that if you fold it, the visual example is if you fold this over once and then fold it over again. So if we folded this, let's say we folded it here, I'm just going to do this dotted just to help you see what it would look like. So we folded it like this to the left one time, and now we're going to fold it down so it lines up evenly with this line right here. And that's what origin of symmetry means. And your ordered pair would be xy here, and then negative x, negative y here. So it makes sense because this is inverted too. So let's say, here's a nice way to look at it. So given this equation, let's rewrite it as negative y equals 1 over negative x. So we want this to become this. So what we want to do, we can't multiply by any constants here. Can't multiply by x or y. But there is a negative sign right there, so what we do is multiply by negative 1. Excuse me, that does not look like a negative 1. Negative 1. And it'll take away the negative signs. So we're left with y equals 1 over x. And that's what the origin of symmetry looks like.